Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is nearing the end of a conversation about complex numbers for a college algebra student, or for those maybe who are entering into differential equations and it's been quite some time, and so you need to kind of review this material. Whichever, it actually doesn't matter. So if you've followed my video series, you'll notice that we kind of dealt with addition and subtraction of complex numbers all at one time, and then multiplication was a separate video. This video is dedicated to division of complex numbers, and it has to be separate from the others just because of the fact that you need all of the other information to do division. It's not that division of complex numbers is difficult, it's just not exactly what you would think. So let's go ahead and talk about it. When given two complex numbers and asked to divide one by the other, we're going to write the division problem as a fraction. That is, if they say, hey, I want to know what 3 plus 2i divided by, let's say we're dividing that by the complex number 2, or well, I guess 3, minus 4i, or something like that. The very first step is to write this as a fraction. So 3 plus 2i divided by 3 minus 4i. Okay, so that's the very first step. And then determine the complex conjugate of the denominator. So in this case, the complex conjugate of that denominator would be 3 plus 4i, and then multiply numerator and denominator of that fraction by the conjugate of the denominator. That's it. And then simplify. So in this case, again, I'll just do it. We're going to take that 3 plus 2i over 3 minus 4i, and we're going to multiply both numerator and denominator, and do not forget those grouping symbols there, by the conjugate of the denominator. So that's 3 plus 4i, and again, 3 plus 4i. When you do that, you just have basically complex number arithmetic to perform here. So in the numerator, multiplying out that numerator there, we get, what is that, 9. I'm distributing like this, so 9 plus 12i. Now I'll distribute the second part here. 2i times 3 is 6i plus 8i, again squared. Remember, I squared is a negative 1. In the denominator, that's a product of complex conjugates, which is something we talked about previously. That's just going to end up being a real number. And now I can start talking about the trick to it. If you multiply complex conjugates, actually we said it in the theorem, it ends up being a squared plus b squared. This is a, that's b. So it'll be 3 squared plus 4 squared. It's kind of a nice way of doing it. And let's go ahead and clean this up. This is equal to, let's see, in the numerator, 9. And remember, this is a minus 8, so it'll be a 1. 9 minus 8. And then plus 18i all over 9 plus 16, which is 25. And you really want to write this as in standard form, as 1/25 plus 18/25 I. So that's how complex number division works. However, I do have this listed as another example, so we might as well do that. Here, I'm going to go ahead and hop back and rewrite the Z1 and Z2 that I'm talking about from a previous video. So this was the Z1 and Z2 from the previous video, and we're asked to divide Z1 by Z2. Let's go ahead and do that. Now, in this case, I highly recommend that you simplify the compound fraction here. In other words, multiply numerator and denominator by 6. It's just a better tactic here. So you get a negative 12, let's see, plus 14i all over 3 plus 3i. It's just much nicer to do that. Trust me, you won't regret doing something like that. And now we're going to go ahead and multiply numerator and denominator by the conjugate of the denominator. And when you do the distribution in the numerator, there we go. We have that written down. Now we're going to go ahead and worry about that denominator. And remember, the denominator is the product of complex conjugates. And so therefore, it is going to just be the sum of the real part squared and the imaginary part squared. So 3 squared plus 3 squared. Cleaning this up, remembering also that I squared is a -1, so that -42 is actually a positive 42. -36 plus 42 is a positive 6. And then we have plus, what is that, 78i? And then the denominator, we have 18. Remember, you do not want to leave it like this. You want to write your answer in standard form. So this will be 6 over 18 plus 78 over 18i. Note that 6 goes into 18 3 times, and 6 goes into 78 13 times? Yeah, 13. So there we go. 1/3 plus 13 thirds I, and I think that the instruction also was graph the result. Not that I want to, but let's just go ahead and quickly do it. All right, that's it for this video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.